Beeping your first active buzzer. Silence. Silence. In Lesson 1, you made a red LED blink using 2 wires and 4 lines of code. Same idea here, completely different output. This time, instead of light, you get sound. 1 active buzzer. 2 wires. The exact same code structure you already know. Let's build it. Think about the last time a machine got your attention with a sound. Your microwave finishing. A seatbelt warning in a car. A smoke alarm. Every single one of those is a buzzer, being switched on and off by a microcontroller, exactly like what you're about to build. Sound is one of the most powerful outputs in any system. It gets attention even when nobody is looking at a screen. A blinking LED is easy to miss. A buzzer is impossible to ignore. Once you can control a buzzer, you can add alerts, alarms, and audio feedback to any project you build. You'll recognize almost everything here from Lesson 1. Here's what you need. Your Arduino Uno. Active buzzer. Male jumper wires. Programming cable. Your standard breadboard. And your ZAS Sensors Creative Board. No new libraries to install. No new software to set up. If you completed Lesson 1, you are ready to go right now. You already know how the Arduino controls an output. High means 5 volts, current flows. Low means 0 volts, current stops. Same principle as the LED in Lesson 1. Inside the buzzer is a piezoelectric disc. When voltage is applied to the disc, the ceramic material physically deforms. It bends very slightly. Apply and remove that voltage rapidly, and the disc vibrates back and forth. That vibration pushes the air around it, creating a pressure wave. And that pressure wave is exactly what your ears detect as sound. Our active buzzer has a built-in oscillator circuit. When you simply apply voltage, set the pin high, it generates its own vibration automatically. You don't need anything complex in the code. Just on and off, exactly like the LED. One important detail before we build. The active buzzer has polarity, just like the LED. Longer leg is positive, shorter leg is negative. Get it the wrong way around and you'll get silence instead of sound. Let's wire this up. You've done this before. 2 wires, 1 component. The only difference from Lesson 1 is what we're connecting. Step 1. Identify the buzzer legs. Look at your active buzzer. Just like the LED in Lesson 1, it has 2 legs of different lengths and a polarity marking. A plus symbol on the top of the buzzer indicates the positive leg. The longer leg is positive. This connects to pin 12. The shorter leg is negative. This connects to GND. Same polarity rule as the LED. Same consequence if you get it wrong. Nothing works. Check it before you plug it in. Step 2. Place the buzzer on the breadboard. Push the active buzzer into the middle section of the breadboard. Place the 2 legs into 2 separate vertical columns, so they are not connected to each other inside the breadboard. Step 3. Connect pin 12 to the buzzer. Take your first male-to-male jumper wire. Connect one end to pin 12 on the Arduino. Connect the other end to the vertical column where the longer, positive leg of the buzzer is seated. Pin 12 will send the high and low signals that switch the buzzer on and off. Step 4. Connect GND. Take your second male-to-male jumper wire. Connect one end to any GND pin on the Arduino. Connect the other end to the vertical column where the shorter, negative leg of the buzzer is seated. Circuit complete. 2 wires, 1 active buzzer. Open the code from ZAS GitHub, link in the description. Let's walk through the key parts. This line gives pin 12 a name, buzzer pin. Every time the code says buzzer pin, the Arduino reads it as 12. If you ever move your buzzer to a different pin, you only need to change this one line. Setup runs once when the Arduino powers on. This line tells the Arduino that pin 12 is an output. We'll be sending signals out from it. Loop runs continuously, forever, for as long as the Arduino has power. Everything inside repeats on an endless cycle, exactly what we want for a repeating beep. Digital write high, 5 volts on pin 12. The active buzzer's built-in oscillator receives voltage and immediately starts vibrating the piezoelectric disc. You hear a beep. Then delay, 1000, 1 full second of sound. Digital write low, 0 volts. Voltage stops, the disc stops vibrating. Silence. Another 1 second delay. Then the loop repeats from the top. Beep, silence, beep, silence, forever. Connect your Arduino to your laptop with the USB cable. Select Arduino Uno under Tools, Board, and your port under Tools, Port. Hit Upload and wait for done uploading. And there it is, your active buzzer beeping on its own. 1 second on, 1 second off, driven entirely by your code. Same code structure as Lesson 1. Different component, different output. That's the Arduino framework at work. Now let's do the same thing on the ZAS Sensors Creative Board. The Creative Board has a dedicated active buzzer already connected to pin 12. Now upload the same code again. No changes needed. Hit upload and your buzzer beeps exactly as it did on the breadboard. Same circuit, same code, same sound, but look how much tidier that is. In later lessons, when you're connecting multiple components at once, this difference becomes enormous. If you face any issues, check the following, or visit the ZAS GitHub troubleshooting section, or post your question on the ZAS Robotics community. All links are in the description. Here's your challenge before the next lesson. Make the buzzer beep 3 times quickly, then pause for 2 seconds, like an alert pattern. You already know everything you need. Digital write and delay. Just repeat the on-off sequence 3 times before the long pause. Bonus challenge. Wire up the red LED and the active buzzer together and make them activate at exactly the same time. Same code structure, 2 outputs, 1 action. All code and wiring diagrams are on ZAS GitHub, link in the description. See you in the next lesson.